So this first question comes from the textbook Stewart, chapter 3, section 3.9, number 3. And it's asking for the rate at which the area of a square is increasing when the area is 16 centimeters squared. So the first thing that we should do is write down the givens. The rate is a given of 6 centimeters per second. And the area is 16 centimeters. And the formula for finding the area of a square would be area equals, sorry I'm using a mouse, side squared. So first we want to find the area. We want to find the side at the moment the area is equal to so what we have is 16 is the area at this moment is equal to side squared, and basically we solve for s, so that would be 16 equals radical squared, and square root and 2 cancels, and we just came to both sides. So the square root of 16 is 4, and that would equal one side. So now we found another constant, which is side equals 4. Let's get rid of this. Okay, so now we have to find the rate at which the square is increasing. So we have the equation a equals side squared, and now we have to differentiate it. So we have to find a derivative. So the derivative of a with respect to time is equal to the derivative of side squared by the power rule is 2s. In general, the derivative of s with respect to time comes out. So after we plug everything in, I'm sorry the handwriting is so bad. After we plug everything in, we have 2, and this s is 4. And ds dt, this rate is given as 6 centimeters squared per 6 centimeters per second. I'm sorry. This is a 6. And the rate of the area would be after everything is multiplied out. dA over D dA with respect to time is equal to 2 times 4 times 6 is 48. 48 centimeters squared. So the sides are increasing at a rate of 48 centimeters squared. And that's all for the first problem. The second problem is from Stewart also, and it's from the same section, 3.9, number 5. And this question is asking about a cylinder this time, and it has a radius of 5, and it's being filled with water at 3 meters cubed per minute. And they're asking how fast is the height of the water increasing. So in this case it would be best to draw a picture first so we get a better idea of what's going on. So I've managed to draw a pretty okay picture. So here we can see that the radius is 5 centimeters and it's being filled with water. And we have to find out how fast the height of the water is increasing. So we can write down the givens now. Well, first we should write down the formula. The formula is cylinder is pi, write it over here, that's pi r squared times h. R squared is, pi r squared is for the circle and h is for the height. So here we have y equals pi r squared times h. And before we take the derivative, we're gonna plug in the values, and r squared is 5, so we have y equals (25 pi times h). And now it's okay for us to take the derivative. So the derivative of y would be dy over dt equals 25 pi and h would turn into dh over dt, which is the derivative of h. So for dy is the rate of the water increasing, the height of the water increasing, and that's given to us in the formula by 3 meters per minute. So here we can replace dy dt with 3 meters per minute. And that equals 25 pi dh over dt. And to isolate this dh over dt, we can just divide by 25 pi. Both sides. And it would cancel over here. And the answer would be dh over dt equals 3 over 25 pi. And the units are meters per minute. Oh, it's meters cubed. And that's it for number 5. For the last problem, I picked something a little simple. It's Stewart. It's from Stewart, section 3.9, number 7. And it's not a word problem, it's pretty simple. If y equals third plus 2x and dx dt equals 5, find dy dt when x equals 2. So the best thing to do here first would be to write the givens. So first we have the equation, which is y equals x to the third plus 2x, and dx dt is equal to 5, and the condition is when x is equal to 2. So the first step would be to have the equation. And we would want to take the derivative of both sides. So dy dt is equal to the derivative of this, which would be equal to 3x squared by the power rule plus 2. And because of the chain rule, over here we have dx with respect to time, which is dt. So now we can plug in the 2 for where x is, and that would equal 3 times 2 squared plus 2 dx and this would equal 2 squared is 4 times 3 is 12 plus 2 is 14, and dx dt is a given as 5, so that would be 14 times 5 is equal to dy dt. And the answer would be equal to 70. And that's it for that problem.